Little video here on basic troubleshooting, sequence of operation. So to start off with your furnace, we got a torn apart 90% Carrier Bryant Payne scenario here, all put back together in pieces on the bench. So that would be your blower motor of the furnace, condenser fan motor. Basically, this is your outdoor unit, your air conditioner minus the refrigeration. Running on 110 because we don't have 220 in here. Contactor, condenser fan motor. All right, so to start off with, we need power, obviously. So your power is typically connected to the board from the main breaker box in the house by these two wires. Today we're using just a cord that's going to plug into the wall, tied into the board, common and line voltage. And if you don't know what your breaker box looks like, that's what she looks like. It's probably in your garage or your basement. And hopefully you got one that's labeled furnace somewhere in there, like I do. And that is going to be a single pole 15 amp breaker. Typically your air conditioner is going to be a double pole, similar to that. Double pole means it's taking 110 volts off each leg coming into the house. So you got 240 for the AC and 120 volts for the furnace. So once you verify you have power, which basically this simulates our breaker being turned on. We should have, if the door switch is pushed in, which is typically the bottom door in your furnace is usually somewhere in your furnace, you're going to have a door switch, which disconnects the power. So we need power from the breaker to the board, which is going to go through a door switch. And then if all that is good, you're going to have an LED light flashing some sort of a code on this particular furnace. Every board and furnace manufacturer is going to be different. But this one, we have a light on, which indicates control has 24 volt power. So, say you turn on your thermostat and nothing's happening down here. The way you can check your thermostat is to, basically a thermostat is 24 volt power fed off of R, which comes directly from the transformer, which is getting our 110 volts out of the board, feeds it back into the board. And if the transformer's good and we have 110 volts, that's going to transform 24 volts to this R terminal here. So that R gets sent up to the thermostat through the thermostat wire and it ends up right here at our R. And you're going to need these four wires. R is power, and all the thermostat does, say thermostat does nothing more than take the 24 volt power from the R that is sitting in it waiting to go somewhere. So you turn the fan on at the thermostat, it's going to attach the R to the G. In other words, letting that 24 volt power go from the stat back down the G wire, and that's going to power up a relay in here, which is going to close and send 110 volts to the blower motor. So we could do that by jumping R and G together here manually to see if our fan control on the stat is working, or we could just turn the fan on at the stat and then our blower motor will run. What else? You could check to see if your thermostat's working by jumping the R to the W and see if your heat comes on. A lot of calls are, I don't think my thermostat's working right. Well, You can either jump W to R right at the thermostat, or you could do it at the board right here. And then your inducer motor should run. First thing that happens on a call for heat. The next thing that happens is the pressure switch should close. Right now we don't have our pressure switch hooked up, and this motor is making an awful lot of noise. But let's just disconnect the inducer motor for the sake of this, because our pressure tubing, which would be hooked on from the pressure switch to the collector box or whatever's going to draw to close our pressure switch, is not hooked up. So say we initiate a call for heat at the thermostat, turn it to heat, turn it up, the inducer motor should be running, and the pressure switch, these two wires right here, the white wire and the orange wire, would be connected to the pressure switch. And right now it's not, and this should go into a fault here shortly, because the inducer motor should be running right now. And we should get a 3 warn code here shortly. Okay, so we're getting our 3-1. Say we close the pressure switch manually by just jumping these two wires, which is what happens when the inducer runs. Now we're going to lose that fault code. The inducer should be running right now. And then our igniter is going to start to glow shortly here. And I just heard the relay closed. It's sending power to the igniter. It's probably going to glow for 20 seconds or so typically. And then there we go. The gas valve just clicked. You've got less than a second to prove flame at the flame sensor, which is hooked to this white wire right here. So the flames would conduct current through the flame to that, and then back to the board through probably that white wire. Now we're getting a different fault code because the flames didn't come on. It's going to be probably a 1-4. Okay, it's a 3-4. So what's a 3-4? Ignition proving failure. So that's what happens when the gas valve does not open. Say the gas valve does not open. Could be a number of reasons. Wire could be off. Coil in the gas valve could be open, meaning burnt or disconnected. Maybe the board's not sending power to the igniter, which we know it is in this case because we saw it glow, but could have a bad flame sensor. Flame sensor could be just mucked up and dirty. Let's take off our call for heat. Open our pressure switch. Now the terms open and closed in heating mean open means disconnected, closed means connected. Closed because those two wires are connected by the way of this jumper. Open meaning disconnected. So that's your basic heating circuit. Air conditioning. Let's turn on a call for cool. When a call for cool is initiated, simultaneously our blower motor will come on. Unless there's a delay, it'll maybe come on a minute or two later. And our condenser fan motor should start, as well as our compressor. So simultaneously, when we put 24 volts across this coil, that coil, when it's energized, is going to magnetize and pull in our high voltage, which I just did manually. So you could do that to see if you have power out there. If you just want to see if you have power, you can just push in the contactor. Of course, don't touch anything metal there. You're going to get shocked. And when you push that in, your compressor should be running as well as the condenser fan motor. So on a call for cool, we should have 24 volts across that coil. Our Y, here's our wires going out to the air conditioner. We have a Y, that's our C, and our Y. 24 volts is sent out on Y, and then it comes back to the board to C, which ends up at one of these two wires. The transformer puts out 24 volts through these. 110 in here coming from the board, 24 volts coming out here, back to the board, and then ends up, basically this blue and yellow is the same as R and C on the board. So we initiate a call for cool. Once this turns down below 60, you'll see the contactor pull in. Okay. Condenser fan motor, as well as our compressor, should be running. You should hear the two different motors. You'll hear that twang in the compressor outside underneath the fan motor. So if you don't hear the compressor running, you could have a bad capacitor. Today we've only got a 5 microfarad cap hooked up to the condenser fan motor. Typically you would have a dual capacitor out at the air conditioner, something like 25 by 5 or 30 by 5, 60 by 5 if you had a 5-ton air conditioner. So the bigger one is going to start your compressor, and the smaller one's going to start your fan motor. So if you see a bloated or seeping oil soaked capacitor, that's more than likely your problem. If one or both of your motors aren't running, and of course the blower motor should be running. If that's not running, you're going to have low suction pressure and you're going to get a freeze up immediately. You'll see white frost on the suction line or the big line at the air conditioner. So that's a call for cool. Other problems you could run into: short in the low voltage wire. Sometimes your thermostat wire exiting the furnace will have run through the cable, shorting your 24 volts to the cabinet of the furnace, or you could have an internal short in the contactor. I've seen it twice, 3 times in 15 years. But if you don't know to look for that, that can be a real joy to find. If I don't see any obvious frays or shorts, sometimes you've got this wire going out to the air conditioner. The weed whip from the lawn guys is taking the coating off of these, and the red and the white are shorted together. That's a simple one. And that would take out the fuse on the board, which should be mounted right in there. I've got a small breaker in place of the fuse right now just so we can demonstrate a short. So your transformer is fed into secondary 1 and secondary 2 fed up through the fuse before it heads to R over here. So if you've got a short to ground outside, that would essentially, let's try and show you short to ground. Okay, here's my wire. That would be just like jumping R to common here. And when we jump R to common or C, you'll see the breaker open. Right there, you just saw that little breaker. I've gotten places the fuse opened up. And we're getting a fault code. Getting a 2.4, secondary voltage fuse open. So I'll reset that breaker or replace our fuse, and we're back to steady on. So like I say, that's short. Could be inside a component. You know, we shorted R to C. R has to go through something and do work. Either, you know, the coil on the contactor at the air conditioner, or the coil on the gas valve. Right there, that would do work. And once you put 24 volts across the gas valve, in other words, a W call, that's going to pull this coil in and open the gas valve and allow gas to go to the burners. Burners need to be lined up perfectly if you ever take them out and clean them. These ones are getting to be, you know, a little mucked up here. So if that crossover, say we're getting a, sometimes this is so mucked up with rust in here that they will not cross over. So you need to pull them out and get a wire brush on them and clean them up. Otherwise, that's going to cause a flame current fault. Your igniter, this one here, is measuring at 100 ohms. You know, I bet this has been in that furnace. I just took this out the other day. It was measuring 90 ohms because it was hot. I just measured it on the bench here, and she was measuring at 100 ohms. So this didn't have much life in it. A new one's going to be right around 60 ohms. Once they hit 100, probably just change them. I like to let them go, but if you're on call where they're, you know, 100 ohms, you should talk the customer into changing it. That one there would still work for how long? I don't know. So, where I've got this breaker plugged in here, I'm going to use this for test. I just took this off a Lennox. The old Lennoxes used to come with those instead of the fuse. This is a board I did last week. The fan was not turning on. Everything else worked, so clearly where that burnt spot is right there is the fan relay that turned the fan on in the heat mode. Worked fine if you just turn the fan on, but that's a pretty bad burnout there. So anyways, if you say you had a furnace that didn't have a fuse, an older furnace, and you run upon a transformer that's fried, what you would want to do is pull off one of the secondary wires and install a fuse in line like so. With the transformer. So burned out transformer, board doesn't have a fuse, just mount one in line with one of the secondary wires and so you don't burn up another transformer. Because if you've got a transformer that's burned out, you've got a short to ground somewhere that you need to find. So definitely put a fuse in there. I don't know what else to tell you. You know, this motor should spin freely like that. Sometimes the inducer wheel, the wheel that's spinning in there will come separated from the shaft on this particular model. And if that wheel is separated, that will not spin more than a couple times. Most of these newer furnaces are definitely going to need a ground. So as you can see, everything looks normal. Steady on. Control has 24 volt power. Let's take and hook this up without a ground and see what happens to our board. So we are just going to plug in this thing that has no ground, like so. Plug in our board. We are getting fast flash. Line voltage polarity reversed. Well, we know that's not the case because it was just working. All we did was disconnect the ground.